Hi viewers, today we are going to learn about most important mechanism is Aldol condensation. So what is Aldol condensation? In presence of dilute alkali like a sodium hydroxide or potassium hydroxide, two molecules of aldehydes or ketone having alpha hydrogen add together to give a beta hydroxy aldehyde, that is aldol, or beta hydroxy ketone, that is ketol. That is called Aldol condensation. So before knowing Aldol condensation, we have to know what are the condition of for the Aldol condensation reaction takes place. The primary condition is if the aldehydes or ketone should containing alpha hydrogen. So what is alpha hydrogen? Let us take acetaldehyde. What is the formula for acetaldehyde? CH3CHO. Here this is aldehyde functional group, that is carbonyl, one of the carbonyl group. So this carbonyl groups attached at methyl. This carbon is called alpha carbon. The first carbon, the carbon in which functional group is attached, that is called alpha carbon. That alpha carbon should containing hydrogen. So if the carbon containing alpha hydrogen, it will undergo Aldol condensation. That is the primary condition for the Aldol condensation taking place. So what is the important condition for Aldol condensation? Aldehydes, ketone should containing alpha hydrogen. Okay, so what is alpha hydrogen? Before that we have to know what is alpha carbon. What is alpha carbon? The carbon attached to carbonyl carbon is called alpha carbon, and the hydrogen atom attached to the alpha carbon is called alpha hydrogen. Clear? So for let us take acetaldehyde. Here the methyl group is the alpha carbon. This is first carbon, that is alpha carbon in which hydrogen is present. Then Aldol condensation may be classified into two types. One is simple Aldol condensation or symmetric Aldol condensation. So what is simple Aldol condensation? Same aldehydes or same ketones will undergo Aldol condensation, is known as simple Aldol condensation. Mixed, next one is mixed Aldol condensation or crossed Aldol condensation. Two different aldehydes or ketones undergo Aldol condensation is known as crossed Aldol condensation or mixed Aldol condensation. Clear? So now we are going to write the mechanism of Aldol condensation. In the Aldol condensation, there are three steps are involved. In the mechanism of Aldol condensation, there are three steps are involved. So before that we have to write the examples for Aldol condensation. Let us take acetaldehyde. What is the formula for acetaldehyde? CH3CHO and one more CH3CHO. So two molecules of acetaldehyde condensed in presence of dilute sodium hydroxide or potassium hydroxide, which form a aldol CH3CHOH CH2CHO. This is aldol. Why it is called as aldol? Because which containing both aldehyde and alcohol functional group. This is aldehyde functional groups CHO, and this is alcohol functional group. So in alcohol which has the al suffix, in aldehyde ALD is a prefix. We can combine both ald and al, then we get aldol. Aldol. So aldol means the compound which containing both aldehyde and alcohol functional groups. Yes. Okay. What is happening in this reaction? So what is the name of this aldol? This is first carbon, second carbon, third carbon, fourth carbon. In third carbon, hydroxyl group is present. So that it is named as 3-hydroxy. 3-hydroxy. Then how many carbon in the main chain? 1, 2, 3, 4 carbon is there. So that it is called as butanol. See, the last suffix is Al, which represent to aldehyde. So 3-hydroxy butanol is the IUPAC name of the aldol. This aldol. Clear? So let us. Okay, now we are going to learn about what is the mechanism. What is the mechanism of aldol condensation? Simple aldol condensation. Mechanism for simple aldol condensation. So let us take acetaldehyde. CH3 CHO plus one more acetaldehyde CH3 CHO in presence of sodium hydroxide or potassium hydroxide. So it form CH3 CH OH CH2 CHO. So already we know this is aldol. Here we can take two same aldehyde. The aldehydes are same, that is acetaldehyde. So that's why it is called as simple aldol condensation. I am already told what is simple aldol condensation. In aldol condensation, both aldehydes are same mean, that is called simple aldol condensation. Okay. So now let us write the mechanism for this reaction. What is the first step? First step is a nucleophilic attack. First step is nucleophilic. First step, listen pass. First step 1 is deprotonation by OH minus ion. Deprotonation by OH minus ion, hydroxyl ion. This is first step, deprotonation by OH minus ion. Let us take 1 molecules of acetaldehyde. I can write like this. OH minus is a nucleophile plus H CH2 CHO. I can write acetaldehyde like this, HCH2 CHO. Right. Here the bonded electrons are shifted to methylene carbon. So H become H plus. H becomes H plus. Clear? Then this OH minus ion combine with H plus ion to form a water molecule. What is the remaining product? CH2 minus. Because the electrons are shifted on the carbon atom. CH2 minus CHO plus H2O is formed. This is called carbanion because carbon atom having negative charge on it. Okay, carbon atom having negative charge on it, that's why it is called as carbanion. This is step number 1. Next step is nucleophilic attack. Nucleophilic attack by another aldehyde. Nucleophilic attack by another aldehydes. So CH3 C double bond O H plus CH2 minus CHO. So already we know the carbonyl group is a polar group. Why? Because the oxygen is a highly electronegative element which attract the bonded electron towards itself. So, these electrons are shifted to oxygen atom. Why? Because oxygen is a highly electronegative element. So, now the carbon become a electron deficient carbon. Carbon become a electron deficient carbon. So, if oxygen getting a negative charge mean automatically carbon getting a positive charge. So, that the nucleophile will attack electron deficient carbon center. Electron deficient carbon center. Then we get a intermediate called CH3 C single bond O minus H, then CH2 CHO. This is second step. Then third step is protonation. What is the first step? That is a deprotonation by OH minus ion. What is the second step? Nucleophilic attack. Then the third step is protonation. Step 3 is protonation. So, we can take that intermediate. What is the intermediate? CH3 CHO minus CH2 CHO. CH3 CO minus here H, then CH2 CHO. So, this is treated with water molecule. So, water is a weak electrolyte which partially ionized. So, O is a highly electronegative element which attract the bonded electron. So, it become a OH minus, H become a H plus. That H plus attached with O minus. So, which form a CH3 COH H CH2 CHO. So, this is aldol. What is the name of the aldol? 3-hydroxy butanol. Butanol. So, this is simple aldol condensation. Here the aldol is less stable compound. The aldol is less stable compound. It readily undergo dehydration to form alpha beta unsaturated aldehyde. So, aldol is a less stable one. It readily undergo alpha beta unsaturated aldehyde. CH3 CHOH. Here I can write CH2 like this, CH2, here CHO is present. So, it will undergo dehydration reaction. So, already I told oxygen is a highly electronegative element which attract the bonded electron towards itself. So, this electrons are shifted to oxygen atom. Then this bond shifted to between carbon and carbon. Then we get CH3 CH, CH. So, this bond shifted to here. So, double bond CH CHO plus water molecule H2O. This is called alpha beta unsaturated aldehyde. This is called as crotonaldehyde. What is the name of the alpha beta unsaturated aldehyde? Crotonaldehyde. This is named as crotonaldehyde. It's the common name. The IUPAC name is Just to give the number from aldehyde 1, 2, 3, 4. 1, 2, 3, 4. Just to give the numbers. 1, 2, 3 and 4. So, first carbon containing having aldehyde functional group, second carbon having a double bond. Totally 4 carbon is there. That is why it is named as bute. Bute means the compound containing 4 carbon. So, bute. Bute. Double bond present at the second carbon. So, that bute 2 ene. The last letter E is replaced by Al because this compound containing aldehyde functional group. So, bute 2-enal is the IUPAC name of crotonaldehyde. So, this is simple aldol condensation. So, what is simple aldol condensation? If two aldehydes, same aldehydes or same ketone will undergo aldol condensation, that is called simple aldol condensation. And another one is crossed aldol condensation. Crossed aldol condensation or mixed aldol condensation. So, what is crossed aldol condensation or what is mixed aldol condensation? Let us take aldehydes and ketones. Let us take aldehydes and ketones. Both aldehydes and ketones should containing alpha hydrogen. It will undergo aldol condensation. So, now we are going to learn about what is crossed aldol condensation. Crossed aldol condensation. Here we can take one aldehyde and a ketone. So, two different aldehydes, two different ketones or one aldehydes or ketones combined together to form a condensed product, that is called crossed aldol condensation. So, let us take acetaldehyde CH3 CHO condensed with acetone CH3 C double bond O CH3 in presence of sodium hydroxide or potassium hydroxide, which form CH3 COH CH3 then CH2 CHO. This is an example for crossed aldol condensation. Now, let us write the mechanism for this reaction. Mechanism. Like a simple aldol condensation, we can write the mechanism for crossed aldol condensation. So, the first step is deprotonation. Deprotonation. Deprotonation by OH minus ion. OH minus ion. So, let us take acetaldehyde. So, I can write the acetaldehyde like this HCH2 CHO. So, when the nucleophile, that is OH minus, approaches acetaldehyde, there is a carbanion is formed like this. So, we get CH2 minus CHO and water. Already we know what is the name of the compound? Carbanion, because the negative charge present on the carbon atom. This is the first step. Deprotonation by OH minus ion. So, here the acetaldehyde prefer to form a carbon ion. Second step, nucleophilic attack. Second step is nucleophilic attack. nucleophilic, nucleophilic attack. So next, let us take acetone CH3, C double bond O, CH3, CH2 minus CHO is the carbon ion which is act as a nucleophile which attack electron deficient carbon center. So the electron present between the carbon and oxygen shifted to oxygen atom. Then we get a intermediate CH3 CO minus this methyl group. I can write this methyl group down the carbon atom. So CH3, then here the compound containing CH2 and CHO. This is the intermediate. Then third step, protonation. Third step is here protonation. So let us take that molecule intermediate CH3 CO minus CH3 CH2CHO is treated with water molecule. Already we know water is a weak electrolyte which is ionized, partially ionized into H plus and OH minus ion. That H plus, here H plus and OH minus ion is produced. This H plus attached with O minus. So then we get the product CH3 COH CH3 CH2 and CHO. So this is named as, what is the name of the compound? CH3 COH CH2 CHO. So let us take, this is first carbon, second carbon, third carbon and fourth carbon. In third carbon, methyl and hydroxyl groups are present. So that it is called as 3-hydroxy, 3-hydroxy, 3-methyl butanol. This is the IUPAC name of the aldol. Okay. So this is an example for mixed aldol condensation. I hope all are understood about aldol condensation, both simple aldol condensation and crossed aldol condensations. Okay. We will meet in next class in the next idea. Okay. Thank you students. Thank you very much.